make sure that's recording, and then we'll get started. So I have a cold today, so if you need me to repeat anything, just let me know. And I'm a little bit. All right, so we're going to talk about section 2.3 this week in class, and then at home you're going to watch the section 2.4 video. I'm going to record it as soon as I get on my lunch break today, so that'll be up by like 12:30. So this section is called linear equations in two variables. A lot of this may be reviewed, taken algebra recently. We're going to talk about like standard form of linear equations. We're going to talk about x and y intercepts, and then graphing. We're just going to do like a little bit of graphing just to practice. All right, so first, I wanted just to give you kind of an overview. Linear equations, these are going to be equations that when you graph them, they look like a line. This is called standard form. I'm not a huge fan of standard form. I prefer like slope intercept form. But a lot of the problems that you're going to be given in the homework will start out in standard form. So I wanted to show you what it looks like. Standard form is where you have your variables on one side. A, B, and C here are just constants. So they're like there's numbers. But A, B, and C here are just constants. Just a number. And X and Y are your variables. All right, so the linear equations have an important property. The highest exponent is 1. So if you have an exponent that's higher than 1, greater than 1, then that's not a linear equation. All right, so that we're going to kind of use that idea as we answer this first question. The first question says, determine if the equation is linear. This is just a yes or no question. Yes, it's linear, or no, it's not linear. So some of this, these look kind of complicated, but really we can just look at these and kind of work them out in our head, determine if they're linear or not. So if you want to write these down, I'm going to give you a second to write those down. We have 4 parts. I think I took this one out of the textbook, but you have something similar to this in your homework. So the first one is 3x minus 8 times x plus 8y equals negative 8x plus y. We have negative 8x plus 11 times y plus 8. On part C, 9x equals 2 minus 9y times 6 minus x. And then you can probably already tell that last one's pretty easy. Probably already tell if it's linear or not. We have negative 2 plus y squared minus y squared. Actually, that one may work out. We'll have to see. Equals negative 9x plus 4. So let's take a look at the first one. So we're just going to think about this one. We're not going to do a whole bunch of work here. Let's think about what would happen if we multiplied through by 8 here, or by -8. Is that going to cause us to have an exponent greater than 1, or do we have any variables that are being multiplied? This would just be -8x. That would be -64y. It doesn't change our exponent anywhere, right? So do you see any, I see 2 variables, that's fine. Do you see any exponents that are higher than 1, or anywhere where we're multiplying 2 variables together? So this is linear. So part A would be linear. And then just a short little explanation. No exponents greater than 1. So I abbreviated that. No exponents greater than 1. No variables being multiplied. So you could call an equation linear, or you could call it nonlinear. That would be like the official term. Something that's not linear. All right, let's look at part B. -8x plus 11 times y plus x equals 3. This is kind of similar to the last one. If we multiply through by 11, it's not going to make any of our exponents greater than 1. We're not multiplying any variables together. So would you say that this is linear or non-linear? Linear, yeah. That one was linear also. The more you look at the word linear, the more it looks like it's not a word. There's no way that's right. So then we have right here 9x times y plus 3 equals 2 minus 9y times 6 minus x. So if we multiply through by 9x right here, you have variables being multiplied together. So anytime you have a variable being multiplied together, that is going to make us suspect that this may be nonlinear. Anytime you have one that you think may be nonlinear, it's probably a good idea just to go ahead and multiply it out and simplify, because the terms may cancel out. So let's see what happens. We have 9xy plus 9 times 3 is 27, so that's 27x equals. The 2 is just going to drop down. -9y times 6, so that's -54y. And then negative times negative is a positive. So that's -9 times -x, so that would be positive 9xy. I'm just writing the variables in alphabetical order. Would those 9xy's cancel out? Yes. So I was thinking we weren't going to have to do any work here, but it looks like we're going to have to. So if it's nonlinear, go ahead and multiply it out, see if the terms cancel. So if we move this 9xy and combined it with its like term over here, it would cancel out on both sides. And let's look at what's left. 27x equals 2 minus 54y. Oops, I just put that. 54y. All right, so the stuff that's left over, is that linear? Yes. So we would say this is linear. Run out of room. Now, when I was reading these off at the beginning, I said you can probably already tell what we're going to suspect this is, right? You see that exponent of 2. That's probably going to be nonlinear. But let's multiply it out and check. Or multiply it out and combine like terms. All right, so let me show you, this is actually a really good problem because this is a common mistake that people will make. Is whenever they see this like squared here, they'll just say, okay, well, I'll just square that one and square that one. That's not how it works. You have to multiply this out. So this, you have to write out as -2 plus y, -2 plus y. You have to actually FOIL that out. If you just square each term, you're going to be missing the middle term. I'm just going to write the rest of the problem here. Minus y squared equals -9x plus 4. Right, so start FOILing that out on the left. -2 times -2 is positive 4. The first, outside, that's -2 times y, so that's -2y. Inside, y times -2, -2y, same thing. I like to write the number in the front. I think it makes it look a little bit neater. All right, and then last, y times y is y squared. Positive y squared. All right, then minus y squared equals -9x plus 4. Do the nonlinear terms cancel? Do the y squareds cancel? They do. Now let's look at what's left. We have just a y, and just an x. Everything that's left is linear. These are actually all linear. So something that would be nonlinear, let me just write you an example. All these end up being linear. This would be an example of something that's nonlinear. You have something that's like xy plus 4x minus 10 equals 17x. I just made that up. It's completely random numbers. So you see we have an xy term, it's not going to cancel out with anything. So since we have two variables being multiplied together, that makes it non. All right, so linear and nonlinear, pretty simple. You're just looking for whether or not you have an exponent higher than 1 or two variables being multiplied together. All right, so we're going to talk about x and y intercepts. This is pretty simple. We're going to do some examples of x and y intercepts, and then we're going to be done for the day. All right, so x and y intercepts. So we're just put two little columns here, how to find the x-intercept, how to find the y-intercept. And then I just added a little note up there that this process actually works for all equations, not just linear equations. So any kind of equation that you have, linear or nonlinear, this is the process for how to find the x and y intercepts. Now your book is going to teach this differently for your homework. But the way I'm going to show you is much easier than what your homework is going to show you. So we have two little columns here. How to find the x-intercept, how to find the y-intercept. Just wanted to mention this while we're talking about x and y intercepts. Your test is coming up on the 19th, I think is when it opens, which is a Friday. So the 19th of February. So that's a week from this upcoming Friday. I think that's right. You'll have like Friday, Saturday, Sunday to do the test. And remember, you can use a index card on the test, a 3-inch by 5-inch index card. I actually brought some today if you want to grab one at the end of class. You can use a 3-inch by 5-inch index card on the test. You can write on both sides You don't have to turn it into me, but I would suggest keeping up with it. If you have to take the final, it's nice to have like all your index cards so you have like a record of what was important for every test. But this might be something that you want to write on your index card, is how to find the x and y intercept. All right, so how to find the x-intercept, very simple process. We're going to replace y with 0 and solve for x. So it's kind of the opposite of how you might think. So how to find the x-intercept, you're going to replace y with 0 and solve for x. Similar process over here. How to find the y-intercept, you're going to replace x with 0. And solve for y. Now, there's two different ways you can write x and y intercepts. It just depends on the textbook that you use. In our textbook, they're going to want the x and y intercept written as an ordered pair. So we're going to just say, write x and y intercepts as ordered pairs. So for example, your x-intercept, remember y is going to be 0, so it's going to be some value for x, we don't know, we'll just say x, but y will always be 0. And then similarly, for the y-intercept, we're replacing x with 0, so the x value will always be 0, and then you'll have to find out what the y value is. Now, whenever you do these on the homework, there's going to be a little option off to the side that says absent. You only are going to use that option if you have some kind of special line that either doesn't cross the x-axis or the y-axis. So the x-intercept is where the line crosses the x-axis, which is the horizontal axis. The y-intercept is where the line crosses the y-axis. All right, so let's say you have like a special line that looks something like this. This is the x-axis, this is the y-axis. If you had a special line look like this is a horizontal line, of course. Notice how it doesn't cross the x-axis. All right, so in this case, you would have no x-intercept. And on the homework, they would say it's absent. So we would say x-intercept is absent. It's not there. So that would be an example of a case where you had an intercept that was absent. They can't both be absent. If they're both absent, there's no line. So one of them has to be there. We're going to talk about special lines and how to spot them, that kind of thing, in just a minute. But first, we're going to do an example of finding the x and y intercept. And then after we do that first example, I'm going to pull one up on the homework and show you how to graph on the homework. And then we'll talk about special lines. Okay. All right, so let's do an example. Here's our first example. Hopefully you can see this. Let me make it a little bigger. All right, so that's our first line. Notice it's in standard form. I don't know why this book really likes giving you lines in standard form. On the test, I typically would give you a line in slope-intercept form, which we haven't talked about yet, but it would look more like this, where the y was on one side and the x was on the other side. It says find the x and y intercepts if possible. If possible is in there just in case it's one of them's absent. And then step 2 on the homework is going to be to graph the equation by plotting the intercepts. This is one way that you can graph lines. is just to plot the intercepts and then connect them together with a line. All right, so we have 3y minus 2x equals 3. All right, so I like to just make a little table, just like I did in the last page. Like x-intercept, y-intercept, keeps it really nice and neat for you. You don't have to wonder when you get to the end, like, wait, which one was the x-intercept, which one was the y-intercept? All right, so x-intercept, we know we're going to replace y with 0 and solve for x. So y becomes 0, so that's 3 times 0 minus 2x equals 3. 3 times 0, that's just 0, so that goes away. So you're left with negative 2x equals 3. How do we get x by itself? Divide by negative 2, very good. All right, so we're left with x equals negative 3 over 2. Notice, I like to put the negative off to the side. It's not wrong to write it differently. You may write it with the negative in the bottom. You may want to write it with the negative in the top. These three numbers are all the same. These are all exactly the same. It doesn't matter if you put the negative off to the side, in the top, or in the bottom, as long as there's only one negative. Just don't put two negatives here, that will make it positive. So I like to put it off to the side, it's totally your preference. X-intercept is done. On the homework, of course, they would want you to write this as an ordered pair. So we would say x value is negative 3 over 2. They may want a decimal. We'll check whenever I pull up the homework. What is my y value? 0. Very good. Yeah, I replaced y with 0 up there at the top. So that's my x-intercept. So it's okay to have negative numbers as intercepts. It's okay to have fractions. Sometimes you'll get lucky and you'll end up with a whole number. But it's okay to have a fraction. All right, so y-intercept, we're replacing x with 0 and solving for y. All right, negative 2 times 0 is 0, so that part cancels. You're left with 3y equals 3. Divide both sides by 3. You're left with y equals what? All right, so tell me the ordered pair of our y-intercept. Very good, 0, 1. Very good. All right, so now we're going to plot these. What's 3 halves as a decimal? Is that 1.5? Yeah. All right, so that just helps me whenever we're going to plot this to know where to put it. All right, so negative 1.5, 0. All right, so x coordinate is negative 1.5, so negative 1 is negative 1.5. Right there. Y coordinate is to go start at the origin, which is right here. Go up 1. There's my y-intercept. Now we just connect those with a line and we're done. Very simple. This is a fine way to graph. It's not my personal preference, but I like graphing this way. You're more than welcome to use this method to graph. Oh man, let's see if we can get it back. There we go. All right. I'm really bad at connecting these, so let's see how good I can do today. Oh, that was pretty good. That's pretty good for me. Usually I miss one point completely. All right, so this is a pretty easy way to graph. Let's talk about the special. Oh, actually, let's first do the example on the homework. All right, so I've got one pulled up here. Again, they've got it in standard form. See how they have both of the variables on the same side? All right, so I'm going to zoom in so you can see this. Find the x and y intercepts if possible. So we have y minus 3x equals 9 over 2. So let's do, I'll do this on the board so someone's watching the recording, they can see it. x-intercept, y-intercept. I don't know if I mentioned this last time, but you want to start bringing your calculator to class. We're going to start using it more and more frequently. All right, so y-intercept, we're replacing we're replacing y with 0, solving for x. All right, so 0 minus 3x equals 9/2. The 0 just goes away. Just forget about this 0. Now we just have to get x by itself, so divide both sides by -3. If you're doing this in your calculator, let me actually pull it up on the document camera and show you how you would type this in. All right, so we have 9/2 divided by -3. All right, so just put the numerator in parentheses. We have 9/2. That tells your calculator, do all this first. This is everything that's in the numerator. Divided by -3. Make sure you use the negative and not the minus. -1.5. All right, so just looking on the computer to see what they want. It doesn't specify if they want fractions or decimals, so I think the safest bet is to use fractions, so that would be -3/2. If you didn't see how I did that, I pressed the math button, and then I selected the first option here, which is frac. You can see the little, if you look closely, you can see that little arrow. That means convert to a fraction. Just hit enter, and it turns whatever your answer is into a fraction. And then similarly, if you wanted to turn it into a decimal, you would just hit the math button, go down to, I keep hitting the wrong button, sorry. You would hit the math button, go down to convert to a decimal, and it would convert it back for you. All right, so -3/2. Let's go back to our screen. All right, so we have, let's see, that cancel. We have x equals -3/2. So if we wrote that as an ordered pair, that would be x value of -3/2, y value of 0. All right, so y-intercept, this one's going to be super easy. You just replace the x value, with 0. Yeah, replace x with 0, solve for y. So y minus 3 times 0 equals 9/2. The -3 times 0 cancels out. You're left with just y equals 9/2. So that's your y-intercept. That would be 0, 9/2. Okay, so let's plug these in, and then we will see how you graph these on Hawks. Right, so -3/2, 0, 0. I'm just using like the little slash button to make it pull up a fraction. Button on your keyboard. It'll make it pop up a fraction. All right, so we'll try that. That's correct. Let's look at the next part. All right, so I'm gonna have to erase all that and then we'll graph it. Keep that in our head, but it's neat. So it was fine with fractions there in your answer. This is the first time I've graphed on here, so we're gonna figure this out together. All right. It says, graph the equation by plotting the x and y intercepts.
Points can be moved by dragging or using the arrow keys. All right, so we're going to drag this point over to our x-intercept, which was -3/2. So about right there. All right, and then let's see, what's 9/2 as a decimal? 4.5. All right, so that was our y-intercept. So 4.5 would be like right there, almost to 5. That was super easy. This is like the easiest graphing tool I've ever seen on a homework system. So you're just literally just taking that, it's going to pop up a point in the middle. You'll just drag it to wherever your intercept is. And it looks like it's okay with, it being approximate. So just drag it to wherever the intercept is approximately, and that will, that'll automatically bring your line up. Okay, let's talk about special lines, and then we'll do one example with special lines, and then we will be done. All right, so special lines. There's two types of special lines, horizontal lines and vertical lines. So we're going to talk about the form that these problems will look like, or the form that they'll be presented in. And then I'll talk about their slope, and I'll draw a picture of what they look like. Which we haven't talked about slope yet. We may actually just talk about slope in the next section, 2.4. So I'll save slope for that video I'm going to record after this class. Horizontal lines have the form y equals a number. So they take on the form y equals a number. So it could be something like y equals 3, y equals -9/2, y equals -100. These are all horizontal lines. So it's going to be a horizontal line through whatever that number is. That's going to be the y value that it goes through. So this is what a horizontal line would look like. So let's do that 1, 2, 3, 4, 5. Let's say that we have the horizontal line y equals 2. It would go through the y value of 2. Do a straight line. And notice that it has no x-intercept. So if you're graphing this on the homework, you would have to use another point other than the x-intercept. So you would just drag it, drag the second point so that it makes a horizontal line. Now you can probably guess what a vertical line is going to look like based on that format. But a vertical line is going to have the form x equals a number. And this is what their graph looks like. X and Y. 1, 2, 3. Let's say that we're graphing the horizontal line, the vertical line x equals -1. So that would be a vertical line through the x value of 1. Mine looks a little bit curved, but that's supposed to be a vertical line. And notice that this one has no y-intercept. It does not cross the y-axis. So it has no y-intercept. So if you spot one of these, they're really easy to spot because there'll be problems that only have one variable. It'll either have an y or an x. If you spot one of these, you know, okay, I'm going to do this problem differently. This is a special line. I'm not going to use my x and y intercepts.
trick. And just notice the last thing I want to mention about these is that it's really easy to find the y-intercept here. It's just whatever this value is. So whatever this value is right here, that's going to be the y-intercept if you're talking about horizontal lines. And this would be the x-intercept, talking about the vertical line.
All right, so let's look at an example. Same question, it's just part B. Find the x and y intercepts in graph.
All right, so we have -6y equals -48. Can you tell, is this going to be a horizontal line or a vertical line? Yeah, horizontal, because it's got a y. So we can tell this is going to be a horizontal line. So just keep an eye out for those when you do the homework. Keep an eye out for those problems that just have one variable. You know, those are going to be your special lines. All right, so we need to find the x and y intercepts first. To do that, let's go ahead and get y by itself. This is a special line, so we have to do it differently. All right, so get y by itself, divide both sides by -6. It's going to cancel out your -6's over here. You're left with y equals 8. All right, so horizontal lines have no, is the x-intercept or y-intercept that they don't have? No, they have a y-intercept, that's where it's going to cross y. Yeah, so they have no x-intercept. So no x-intercept is going to be absent. The y-intercept is given to you once you solve for y. All right, so remember y-intercept, the x value is always 0. Y value is whatever you get once you solve for y. So it's not difficult to find the x and y intercept when you have one of these special lines. It's just remembering to do it differently. Remembering how to spot these special lines. All right, so no x-intercept. So we're just going to plot our y-intercept, which is 0, 8. So this is 10, that will be 9, 8. Y'all told me this is going to be a horizontal line. So if you're dragging your point, like from here, you would just drag it to right beside it. Anywhere on that line is going to be fine. All right, so then just draw your horizontal line. You're done. That's y equals 8. Super easy to graph those special lines. Okay. Any questions? We feel okay?
Let me look at, the next section is about slope. So I'll tell you the definition of, or the formula for slope. There'll be two forms of special line, or excuse me, two forms of linear equations that we'll look at, slope intercept form and point slope form. So it shouldn't be too long, only 8 slides. So that video will be up, like I said, by 12:30 today. All right, so like I said, the test will open on the 19th, so I'll talk more about the test next Monday. But if you have any questions in the meantime, please let me know. All right, thanks for coming today, you guys. I'll see y'all next week.